So I'm going to be demonstrating number 24 from the Chapter 3 homework set. So the problem reads, a student stands at the edge of a cliff and throws a stone horizontally over the edge with a speed of 18.0 meters per second. The cliff is 50.0 meters above a flat horizontal beach as shown in figure 3.24. How long after being released does the stone strike the beach below the cliff? With what speed and angle of impact does the stone land? So as given from this diagram and the one I drew right here, the initial is 18 meters per second. So I just made x equal to 0 right here. So this way is going to be positive. And it's 50 meters above. He's standing on a cliff 50 meters above and the beach is right here. So the first thing you're going to want to do is set up your x and y table. So find your givens, which is 18 meters per second of the initial velocity. The final velocity is also 18 meters per second. The acceleration is 0 because the object is not speeding up or slowing down. And the y's, which is 0 meters per second for the initial velocity. And the acceleration is negative 9.8 meters per second due to gravity. So the first thing you're going to want to find is the time. How long after being released does the stone strike the beach? So basically, when is it hitting the ground? So to find this, you're going to use this formula and plug in all your givens, the y givens, because you're finding how long after being released will it hit the ground. So you plug in all your givens, negative 50 meters below, because since I made x 0 where he's standing on the cliff, the ground is 50 meters below 0, so it's negative 50 meters. So negative 50 meters, and then the initial velocity, and then the acceleration due to gravity, and then time is unknown. So you solve for t, and you eventually get 3.19 seconds. So that's what I have here. The time for both the x and the y are 3.19 seconds because the time up equals the time down. So next thing you're going to want to solve for is where is it landing on the ground? How far from the cliff is it landing on the ground? And to do this, you plug in to this part of the equation, the VI times the time. So when you plug in the initial velocity and the time that you just got from the previous question, you're going to get delta x equals 57.42 meters. So this distance right here is 57.42 meters. After that, you're going to want to find the velocity. So what speed and angle is of impact does the stone land? So what speed is it traveling at? So the final velocity you're going to want to solve for. So you plug all your givens in, and when you do that, you're going to get negative 31.26. So since you have the Pythagorean theorem to solve for this angle right here, you can get the angle theta. So you solve for tan theta. So basically one side, this side is going to be 18 meters per second. The side that you just solved for, the speed and angle, so the speed is going to be this side, which is negative 31.26. So when you're solving for theta, you're going to want to do opposite over adjacent. So you plug in that, and eventually you'll get negative 60.1 degrees. So basically the final answer is that the object is traveling at 36.1 meters per second, 60.1 degrees below the x-axis, below the positive x-axis, because the degree is negative right here.